Hi class, today we are on Saxon Math, Book 4, Lesson 32, which is multiplication facts for 9s, 10s, 11s, and 12s. So I'm going to follow the book a little bit for this one. There are some example problems that I do want to look at with you just to kind of show you the format. However, the main reason I want you to tune in for this lesson is because I'm going to share with you the tricks to 9, 10, and 11. 12, not so much a trick. Those you kind of just have to memorize. But let me show you the 9s trick. So I think this works better for me to turn around so that you see with my hands what you're going to see with your own hands, because the trick for 9s is to use your fingers, okay? So if we look at our 9s, you see your hands like this, and if I want to do 9 times 1, I put down my first finger, and I don't have anything over here to the left of my thumb. So everything that's to the right of my thumb are 1s. 9 times 1 is 9. I have 9 fingers. Now, if I want to do 9 times 2, I put down my second finger for the 2. Now, see over here, I have something over to the left. This is a 10, and these are all 1s. So now I have 10 plus 8, which is 18, and 9 times 2 is 18. 9 times 3, I have 2 10s and 7 1s, so that's 27. 9 times 4, 3 10s, 6 1s, 36. 9 times 5, 4 10s, 5 1s, 45. 9 times 6, we come over to our second hand because I had times 1, times 2, times 3, times 4, times 5. So now I put this finger down for times 6. And I can't bend that one quite as well. But I have 5 10s and 4 1s. So 9 times 6 is 54. 9 times 7, these are all 10s. I have 5 over here, plus I have another 10 here. So 6 10s, 3 1s, 9 times 7 is 63. 9 times 8, my 10s are really racking up here. 5, 6, 7 10s, 2 1s, so I have 72. 9 times 9, 8 10s, 1 1, 81. And 9 times 10, they're all 10s, so 90. So you can do 9 times 1 all the way through 9 times 10 just with your fingers. Easy enough, piece of cake. You carry them with you all the time. Just remember that trick. Now, I do want to look at these problems, or at these answers. 9 times 1 was 9. 9 times 2, 18. Times 3, 27. Times 4, 36. Times 5, 45, times 6, 54, times 7, 63, times 8, 72, times 9, 81, and times 10 is 90. So for times 1 all the way through times 10, if you guys were here in person, I would say, what patterns do you notice here? What do you see about these answers? And there's a couple that we always find. The first one that everybody notices right away is, whoa, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then alternatively, they see this, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And look, I could even put a 0 in front of a 9 here and complete that pattern. So that's the first thing that my students usually notice. Sometimes it takes a little trick or a little hint from me to notice the second thing that I want you to see, and that is I put a little plus sign between each of these digits. When I do that plus sign, what else do you notice that is special about this group of numbers? If you add the digits, they all equal 9. So that's another trick with your 9s from 0 to 10. Now, if we do 9 times 11, we get 99. So that doesn't work. That trick doesn't work. 9 times 11 through 9 times 20 doesn't work. And above 20 as well. But for the 1 through 10 multiplication factors, they all equal 9. Isn't that weird? Well, this pattern is what makes your finger trick work. Because if you bend down one of your fingers, how many fingers are you left with? 9. So we add our 10s, we add our 1s, and we end up with 9 fingers. That's what makes the finger trick work, which is kind of cool. All right, so there's my 9 spiel, my 9's trick. I love the 10s. You give me any problem times 10, and I've got it like that. 10s are my favorite, because here's the 10s trick. You take whatever number you're multiplying, you write it here, and then you look at the 0 there, and you tack it on at the end. So 3 times 10 is 30. 16 times 10, I take this number, 16, and I tack on a 0. Because what is 1 times anything? Itself, right? So I've got the 1 times 3 up here. I've got the 1 times 6 up here. But since I'm not multiplying times 1, I'm multiplying times 10, I'm going to end up with a 0 in my answer, in the ones place of each of my answers, anytime it's times 10. Okay? So this is the easiest one. I often will say, okay, what about 5,672 times 10? And we use the trick and we say, well, it's 5,672,0, and then we can put in our comma to read it as 56,720. Takes hardly any effort. So the 10s trick is totally awesome. All right, the 11s also have a pattern. So let's write down those. If we count by 11, we say 11, 22, 33, 44, 55, 66, 77, 88, 99, and we'll stop there because that's where the pattern ends. But we know from our 10s trick that 10 times 11 is going to be an 11 with a 0 at the end. So our 10s trick can show us that. But what do you notice about 1 times 11 through 9 times 11? We're just repeating the digit. So 1 times 11 is 2 1s, 1 1. 2 times 11 is 2 2 or 22. 3 times 11, 33. 4 times 11, 44, and so on. There's my 11s trick. All right, we're gonna look at our 12s. There's a little bit that we can notice about them if we look at them in a list. So we have 12, 24, 36, 48, 60, 72, 84, 96. If I want to keep going, I'm going to get 108, 120. We'll stop there for now. So take a look at it. Think about the patterns we saw with the 9s. You might have noticed we've got 1, 2, 3, 4. We skip 5, and then we have 6, 7, 8, 9, 10. Notice here we still have a 10 after the 9, and then we skip 11, and then there's a 12. So little bit, the ones place mostly count, because think about it, if we're adding groups of 12, we're adding a new 10 each time. And every time you get to the 5th group, so this is 1 times 12, 2 times 12, 3 times 12, 4 times 12. When we get to 5 times 12, well, we're multiplying the 10 5 times, which is going to give me 50, but then we're also multiplying the 2 5 times, and 2 times 5 gives me an extra 10. So that's why here between the 48 and the 60, we skip a 10. We don't have 50 something as an answer for 12s. And then down here again, once we have 10 12s, when we do between the 9th and the 10th, we end up skipping one because we've got another group of 10 ones that is going to become a new 10, okay? The other thing that you might notice that can help you out when you're doing 12s is the ones place counts by 2s. We have 2, 4, 6, 8. Hey, look at that. There's my 10 that we've skipped. We've made a 10, so we skipped the 5 and said 6. Then we start again. 2, 4, 6, 8, 10. So that's a pattern. I don't find the 12s to be quite as easy to figure out with any kind of trick. However, they seem to be fairly easy to memorize. So work on your 12s at the very least from here to here, from times 1 to times 5. Just count by 12s, get up to 60, and once you've got that down pat, maybe add up to 72, then to 84. So on your multiplication table that we're going to start filling out come January, you will need to know this is 12 times 10. See the 12 with the 0 tacked on? 132 is 12 times 11, and 144 is 12 times 12. These two tend to be kind of tricky to remember. But that is as high as you need to go. That's as high as you need to have memorized for your math fact multiplication tables, okay? So I promised you that I wanted to look at a couple of book examples. So what you will see with this multiplication facts are a bunch of tables. So they have something like find the number of millimeters that equal the given length in centimeters. So they'll make a table like this. And actually they go to 12 and I didn't leave myself room to do that. So let me do it on the board. They'll make a table like this. Centimeters, millimeters, and then they'll have this filled in 1 through 12. And they'll start by saying 1 millimeter is equal to 10 centimeters. And actually in this example, they go all the way to 4. 4 centimeters is equal to 40 millimeters. And then they say, fill in the rest of the table. So you can see a pattern here. So this is really a pretty simple type of problem. But we've got 10, 20, 30, 40. We're counting by tens. There are 10 millimeters in each little centimeter. So we'll continue counting by tens here. Excuse my bell. And then the important thing is that you can read this table, that somebody could say, hey, how many millimeters are in 11 centimeters? And you go, okay, this is centimeters, so here's 11. Oh, there's 110 millimeters in 11 centimeters. So these tables can help you out with that. Another example they give is find the number of inches in 12 feet by completing this table. So here, instead of centimeters, they have feet. And instead of millimeters, they have inches. The top is still filled in up to 12, but we're not counting by tens anymore, so I'm going to get rid of our work here. And instead, we need to know that there are how many inches in 1 foot? 12. So if 1 foot has 12 inches, how many inches are in 2 feet? Well, we'd have 12 inches here plus 12 inches here. 24 inches. This is where I said counting by 12s is going to come in handy. How many are in 3 feet? 12, 24. Do I remember my pattern? 36. Then 48. Oh, this is where we skip one. We go to 60 plus 12, 72, plus 12, 84, plus 12, 96, plus 12, 108, plus 108, plus 12, 120, plus 12, 132, plus 12, 144. We filled it in, but we haven't answered the question yet. The question says, how many inches are in 12 feet? Read my chart. It says 144. So 144 inches would be the answer that we're looking for. Okay? Boys and girls, there are a whole bunch of multiplication practice problems on page 202 of your textbook. So if you'd like, you can turn there, do the lesson practice problems. If you think your time is better spent spending 10 to 15 minutes on MobyMax, go ahead and do that type of fact practice. And then your written practice also starts on page 202. So have a great day. We'll see you again soon.